Login acceptance.
Okay, I think that's pretty much everyone right now. So let's get started. A tale from the trenches. We initially got our database schema wrong, and now we have millions of users. Or actually, how to evolve the database schema. So who has had this problem before of evolution of database schema? Yeah, it's quite a lot of people. Those who don't put their hands up. Why are you here? Okay. A few words about me. I'm Maciej Przepióra. I'm working for Atlassian. Before, I was working for Spartes, a Polish company that was a subcontractor of Atlassian. And I worked on Jira DC, Jira Server. Right now, I'm in the Jira Cloud team. I develop Jira Cloud. So, not many angry faces, that's nice. Okay. That's good to know that there isn't many people angry with me. Okay, this is the first time I'm presenting this presentation, so please bear with me if I occasionally stutter or have a problem with explaining some idea. You are encouraged to ask questions during the presentation, and we will have a Q&A session at the end of presentation as well. So if there is anything that you don't understand, please just stop me and ask a question immediately. Okay, so how do we evolve the database schema in Jira Cloud? We use Flyway. Thank you. Do you have any questions? Do you have any questions? We'll get to that, because it's not really true. We're not using Flyway DB only. It's true, but it's only part of the truth about Jira Cloud, because Jira Cloud has lots of its own peculiarities, and those peculiarities affect how we need to work on the database schema, and how do we evolve this database schema. So let's talk about those peculiarities first, so that you can build some mental image of what are we actually dealing with in Jira Cloud. So let's talk about those peculiarities. The first peculiarity, the most important one, Jira is 19 years old. And Jira Cloud is actually the development line, in the same development line that started 19 years ago. So that's quite a lot of, how to put it, legacy. That's well, you could say that this is a very mature product. And that's true, it is a very mature product. Then we kind of are screwed with the fact that we're using non-standard object relational mapping tool, which is called OffBiz. Someone heard about it? No one have heard about it. So this is an Apache library that was developed for some kind of ERM software that Apache Software Foundation develops, and it's pretty much them and us using it, and no one else. So we need to take care of this ORM layer as well. We need to apply patches. We need to maintain it. It's not source code, open source code library. Well, it is open source, but it's that only we can maintain it. Yes, you had a question.
Yeah, so basically, almost all ORM libraries are pretty old. Why this one?
So at the moment it was chosen, this was the only ORM tool that supported multi-tenancy. And that was the reason it was chosen, because this was before the so-called fork. I will talk about this in a moment. But in the beginning, when Jira started running in the cloud, it was the same product as Jira Server. We had lots of virtual machines that it was running on. And then we came up with this idea that, well, running virtual machines, that's pretty much heavy, and we probably need to diverge somehow from the server code. And OffBiz was chosen for this particular purpose because it was the only one that supported multi-tenancy out of the box. So yeah, I was talking about this before. Jira has been forked. So that has happened something like, I think, 7 years ago or so. when it was decided that the on-premises model and cloud model are so much different that we just cannot maintain one code base, because it doesn't make sense to cater for all the necessities in both cloud and data center. So that's why we performed the fork, and we ended up with 2 different products, in fact. But there are some differences between those products. The DC version, the one that runs on premises, it has to support different RDBMS, like Oracle. Lots of our customers are using Oracle. Some people are using MySQL. Other people are using Postgres. And in the cloud, that's pretty much easy because we were running on AWS. We use RDS as a database backend, and it's Postgres only. For some of our customers, we actually moved them to Aurora if there are big instances, because Aurora helps us with maintaining the good performance. But still, it's Postgres, right? So there is only one database that we need to care about, and that makes things so much easier for us than for the guys in the DC. Anyway, but because of the fork, we need to support migrations of our customers. So it is possible that we have a customer that is using Jira DC, and then they want to move to the cloud. And not only that, but if they have used Jira Cloud before, and they have grown so much that they tell us that, well, Jira Cloud doesn't have capabilities that we need. There are in DC version. Can you help us move from Jira to the DC? And of course, we're moving lots of capabilities from Jira DC to the cloud. We're adding new features. But still, there are some customers that tell us that Jira Cloud is too slow for us. We want to run it on premises. And because they have lots of issues, lots of projects, they want to move to DC. And we need to support them with that. So it needs to be possible to take data from Jira Cloud and move it to the Jira DC, and other way around. So how do we deal with migrations? That's the first problem that we need to solve with database evolution. We need to support migrations. And of course, we could come up with some arbitrary format for the data that you just take and use for moving the data between DC and cloud. But for historical reasons, what we did is that when you're exporting a full Jira site, a full Jira installation, you're exporting the content of the database that backs this Jira, right? So it's actually 2 XML files. One is the definition of the schema of the database, the one that our ORM tool uses actually for generating classes and all that stuff and generating tables. So that's the entities XML file. And then there is the actual content of the database in the XML. And when we import data from this file, we're actually reading the XML file and filling tables. And the problem here is that, well, we have a divergence here, right? So the database evolves differently for the DC version, for on-premises version of Jira, and differently for cloud version, right? So it's not that you just can take this XML file and stuff it from Jira DC to Jira Cloud. No, that wouldn't work, because there are different database schemas. So we need to think about one more thing, because there are also plugins, and we need to support plugins data like Jira Software, Jira Service Management, and so on. So I'm going to leave it because it makes the picture so much more complicated that I'm not going to talk about it now. But let's just focus on the divergence. So we came up with upgrade downgrade task framework, and we specified that for the DC, we wanted to know how to upgrade from this pre-fork point, right? So this is the version 7.107, right? This is this common version that both Jira and Cloud know and know how to import data for. And when the DC version of Jira exports data, it exports it as it is. And now, when we want to import this data to cloud, well, there are a couple of things. Cloud knows how to upgrade from the pre-fork point. So it knows how to perform all the changes in the database schema if we started from the pre-fork point. If we have an export running, we're exporting data from Jira Cloud, and we want to import it to the DC instance, we have so-called downgrade tasks that basically roll back the changes in the database schema, and then export this XML file with the data, right? So now we know that server will be able to import it because it knows how to upgrade the data from the pre-fork point. And if we run an import from data center from DC version, we run an import to the cloud, we run so-called DC downgrade. So those are corresponding DC downgrade tasks that roll back the server version, the DC version of Jira database. And we perform all these tasks in a separate database so that it doesn't affect the currently running instance of Jira. So whenever there is an import or export happening, we are actually cloning the database and we're running this whole operation on a separate database so that whatever happens there doesn't affect the currently running instance of Jira, either cloud or DC, yeah?
Does it mean you're losing data when migrating from cloud to DC and back?
So the question was, does it mean that we lose data when we migrate between DC and cloud or other way around? Yes, it might happen. But usually, it's not that we're losing important data because the most important things in Jira are issues, users, epics, and things like that. Those will stay. But we usually change the database schema so that we can either support something new, and then we have some other mechanisms catering for that. So there's some other export mechanism that you can use. But most of the changes are actually about denormalizing data, for example, for performance reasons. So it's not that you're losing some data. Okay. One thing about upgrade tasks is that we need them to be very low level, which means that there is no managers or services or anything like that, very high level things that allow you to, for example, create a user out of thin air or anything like that. It's just raw SQL. Maybe a bit higher level than JDBC because we're using query DSL, but it's basically very low level. And the reason for that is because we are running all upgrades against the data shape at the time of the writing, not at the time of running the upgrade. So if we have data transfer objects, they can evolve. And they will evolve if we change the schema, right? But we will not know that until it actually happened. So we cannot use those high-level vehicles in Jira. We cannot use things that help us with creating objects in the database. We can only use a bare DB connection for that. So an example upgrade task looks like this. So basically, we inject a query DSL accessor that's basically a wraparound database connection, and we then use query DSL for deleting something or from creating something or denormalizing data. If you want to, that's highly encouraged. You could use just bare SQL, but that's not type safe. Well, that would be frowned upon if someone saw something like this in pull request. So it would probably not pass the pull request review. Okay, so the question is, we have those upgrade and downgrade tasks, but when those tasks should be run? And this depends on the model of deployment, because if we have a data center version of Jira, it's customer's call. They run in Jira, they decide when to upgrade it to new version. And in the cloud, it's not so happy path because we're on continuous delivery train, and this means that we have code deployed to production every day. There is no such thing as maintenance window or anything like that. It needs to work all the time. So in case of DC, since it's customer run in Jira, it's up to them to decide when upgrades are run, but there's one caveat here. In this world, data upgrades are part of the cluster upgrade procedure. So when you actually upgrade in Jira DC, and you're upgrading it to the newer version, the data upgrade will be part of this procedure, right? So when the version of Jira changes, we actually run upgrade tasks that it's part of the startup of the first node that is upgraded in the cluster of Jira DC. Okay, and we came up with a procedure that allows you to avoid any downtime, and it's called zero downtime upgrade, or ZDU. It's a bit similar to what we do in the cloud, so I actually won't go into details right now with that, because there are some more Jira Cloud peculiarities. The first one already mentioned is that Jira Cloud is on a continuous delivery train, so it means that we cannot control data upgrades as in DC. We cannot have a maintenance window or anything like that. We need to make sure that everything works all the time. And this means that there is no guarantee that a change to the database schema and a change to code that knows about this change in DB, a corresponding code change, will be deployed at the same time. We just cannot know it. So that's one thing. The other thing is that Jira is really big. And I'm thinking about many things here. One thing is that we have hundreds, thousands of tenants, and each tenant in Jira has its own database. So that's one thing. We have lots of databases to maintain. Each of these tenants can have up to thousands of users. So in total, we have millions of users. And this means that since we're providing a service to customers that are depending on this service, we need to be very careful about not breaking this. So every change that we put on production needs to be rolled out gradually. We need to have some kind of gradual rollout procedure. It's not that we can just do a big bang release that everyone gets the same version of database at the same time. Because if we did that, and there was some issue with, for example, the upgrade script that is just performing very poorly, it would mean that we would screw up all of our customers. And one of our values as Atlassian is that we don't fuck the customer. Okay, so we came up with a procedure that is, well, it's pretty much the same as in ZDU in the server world. It is called Fast5. So, someone saw the movie? Who has seen the movie? Oh, okay, one person. I haven't seen it, don't worry. But we have actually 5 stages that we move through. So the first stage is everything is fine. We have the code, old data, old data code, the code that deals with the data. We have old schema, old behavior, so everything normal. Then, in the second stage, we're deploying code that handles old and new schema, but we have still old schema. The third stage is old and new data code, and we trigger the update to the schema, but we still present the old behavior. Fourth stage is old and new data code running together. The schema is already upgraded, so we can present both old and new behavior because this is a gradual rollout, right? So some tenants are already upgraded, some will be upgraded, so we're presenting both behaviors depending on the tenant. And then when every tenant is upgraded, we move to the fifth stage. We have new data code, new schema, new behavior. So we basically back to point 1, right, to the stage first. So, excuse me, stage 1 is running as is. Stage 2 is deploying the code that handles both old and new schema, and we have some way of controlling which branch of this code is executed. Stage 3 is upgrading the schema, initiating the upgrading of schema, and stage 4, switching the code to use new schema, and stage 5 is back to stage 1. So let's talk about stage 2, when we are deploying the code that needs to be able to handle both old and new schema, right? So when you're developing on your local machine, you can perform the upgrade locally, and then you can develop against this new version, but you still need to think about tenants that are not yet upgraded. So you need to have some branching logic, right? If we are on a new version of the schema, then execute the new code. If we're on the old version of the schema, just do as you did before. What we can also do is that with this change that supports both new and old schema, we can deploy the code that performs the change. So we can deploy it at the same time. We just don't trigger the upgrade yet, right? We can just move the point in the time when we actually will trigger the update. So we'll just trigger this upgrade task at a suitable time. Questions? Everything is clear so far? Okay. So now that we have code that supports both old version and new version of the database schema, we can trigger the update, right? So now we know that the code will support eventually new version of the schema. And we actually trigger the update gradually. We have something that is called a per tenant loop. So this is a tool that allows us to perform different operations on each tenant, and we can schedule the execution over 24 hours window, for example, right? And then we can start observing what's happening if upgrades is running fine and so on and so forth. So that's the important thing. The data upgrade needs to be rolled out gradually, because if something is broken, we don't want to screw our customers. We want to stop the upgrade, for example, move back to the previous stage, and that's it. So for some upgrades, we can also use feature flags. Do you know what a feature flag is? Do you want me to explain it? No? Okay. Okay, so that's the stage third. And in the fourth stage, we can flip the, for example, flip the feature flag and tell, okay, so now start using the new schema because it is deployed. We know that it's completely rolled out, and just start using it. Code was there in stage 2 already. It's just a flip, a feature flag switch, so that it can move to the new branch. And in the stage 5th, there's one important thing as well. Everything is fine because we upgraded the database, the code knows about the new schema, but now you need to do the cleanup, right? For example, remove unnecessary data from the database, or remove an right now unused feature flag. And that's it. A few words about removing data. Since we need to support import and export both ways, Jira Cloud, Jira DC, we'd rather not delete tables or columns because that would break the XML files, right? It's possible to do that, but it's very cumbersome, and basically what is easier to do is truncate the table, remove the data from the table, but keep it there. Or if you were removing a column, just fill it with nulls. And that's what we do. And that might feel a bit awkward, but that's the normal thing in Jira Cloud. We do that way, and it works for us. Okay, so let's move on to, let's move back to upgrade tasks. One thing about upgrade tasks is that we cannot use feature flags there because they are running when the Jira is starting, and we don't have access to feature flag service there. And there's one more problem with upgrade tasks, that if you want to do a big change in the schema, the problem is that you need to run upgrade tasks everywhere. You cannot just limit it or gradually roll it out. There is this PTL I mentioned before, per tenant loop, that allows us to spread the upgrade over 24 hours, but anything else is ruled out, right? So if you want to roll out the feature using feature flag upgrade task from this upgrade downgrade framework, it won't work for you. So we had to come up with something that we could use to limit the blast radius of a poorly performing upgrade task. And let's talk about more Jira peculiarities. Have I mentioned that before? Jira is big, which means this is a big code base. This is a big monolith. I haven't counted the number of lines of code, but it is big. I mean, there is no single person that can know about everything in Jira. Which means that Jira Cloud is developed by a big team. That's definitely not a 2 pizzas team. I mean, those would have to be really, really big pizzas, like, I don't know, 20 meters in diameter or something like that. I think it's a couple of hundreds of developers right now, and we're growing. So when you're developing some changes, it's very easy to step up on someone else's toes. And if you want to build many upgrade tasks in parallel and run them with the pertinent loop, there is no way to roll out only one task. Because pertinent loop works that it tells, OK, Jira, upgrade to the latest version of the schema. Right? And if there are like 3 or 4 upgrade scripts or upgrade tasks at the same time, all of them will be performed so that Jira is up to date with its database schema. So we had to come up with something else, and that's why we came up with an ad hoc upgrade task, or AHUT, framework. A couple of things about AHUTs. First of all, the changes that they perform are incompatible with DC export. So this has to be taken care of later when you actually roll it out. AHUTs don't run on all tenants because they're not, for example, executed on tenants that are suspended for some reason. Like, for example, they're not paying. So we're suspending their instance. And if they actually are unsuspended, we need to manually raise a request with our SRE team so that they manually invoke this ad hoc upgrade task for those particular tenants. But one thing that is nice about AHUTs is that they're very suitable for high-risk changes, because we can use feature flags in them, and we can roll out the change progressively to mitigate the risk. We can employ all kinds of observability in those tasks and see what is happening if, for example, the upgrade task itself is performing very badly and it affects the database performance. Or maybe it is causing some, well, let's say we're adding an index to the database and it completely destroys the query plan. And it means that for some tenants, well, they will see like 30% better times, the 30% better performance of their queries, JQL queries, for example. But there is one tenant that will get things worse by 100%, and we need to roll it out. So that's why AHUTs are so good, because they actually allow rolling things back. And on a completion of a rollout, an ad hoc upgrade task either needs to be removed or converted to a regular task. And this is some additional development cost that needs to be taken into account. But yeah, still, as I mentioned before, there's one more nice thing about AHUT is that it allows to define rollback. But you need to be careful with that as well, because let's say you have some AHUT that performs the change, 2 days passed, and then you decide, well, that was not a good change, we need to roll it back. But what could have happened? Exactly that. So what could happen is that customer actually, or our user, did something that changed the data in the new shape already, and then if we're performing a rollback, we're basically removing their changes. And that's something that they won't be happy about, I can tell that. Okay. One more thing is that since we're heavily invested in observability, an upgrade task must report its progress every 5 minutes at least. It can do it more often, but if it has stalled, if there is no progress, it will be pronounced dead. And that means that, well, you don't want to happen that, because this ends up in SRE team being angry at you as a developer. And you want to live on a good terms with them. I can tell you that. Okay. AHUTs are also very low level, so there is query DSL that we use for changes, and that's pretty much it. So let's take a look on an upgrade task. Well, there's a key that allows us to call this task by a key. We have internal REST endpoint that is not available from the outside of AWS. So that's one thing. This key needs to be unique for all the tasks, all ad hoc upgrade tasks in Jira. There's some description. This is used for by SREs when there's something going wrong. We call this method so that they can see what is actually the task that is failing, and not just the key of the task. This is enabled because, well, usually it's just checking the feature flag, but you can do some other use some other logic. I haven't seen it in the code. Usually it's just checking the feature flag. If the feature flag is enabled for the upgrade, then we're just performing the upgrade. And then there is also should auto-execute because, as I mentioned before, we have this per tenant loop. This per tenant loop invokes Jira on average every 24 hours so that it is up to date with the database schema through ad hoc upgrade tasks. And then there's one more thing, the actual upgrade. So we get this task progress writer that we can use to inform observability about changes in the progress of the task. And that's it. There's also a very more specialized version of ad hoc upgrade tasks, the rollback reversible ad hoc upgrade tasks that allow you to perform the rollback. This is useful for things like adding constraints or new indices in this schema, because if you see that this is not a good change, you can just you don't need to do pretty much anything. You just flip the feature flag, now move to the rollback mode and just roll back the changes. So, as I mentioned before, AHUDs are executed automatically and can be also forced manually. And that's pretty much it about them. They're very useful, but in the end, you will always need to perform a transition from an ad hoc upgrade task to a regular upgrade task so that you can make, for example, the change compatible with exports. Okay, did I mention Flyway in the beginning, right? So yeah, we also use Flyway for database evolution. It's much easier than using upgrade tasks because it's just pure SQL scripts, right? And we usually use that for schema changes that are excluded from to-server export because we have some configuration in Jira that tells, okay, don't care about these tables when doing the export, or don't care about these columns in the export. It's fine, just don't put them into the XML file. And with this in place, we can do whatever we like with Flyway, right? Because this is a one-way ticket, basically. Okay, and we use Flyway. We can use Flyway scripts as a last step, the stage 5 in Fast 5. The one when we perform the cleanup, we're removing the upgrade task and an ad hoc upgrade task, and we're transitioning it either to regular upgrade task or a Flyway upgrade task. Okay, you might wonder, what if something goes wrong during the upgrade? Right? Did I mention that before? Jira is big, like really big. And this means lots of logs, data, and so forth. So we have things for observability like Splunk, log collection. We use SignalFX. We have alerts set up there. We use Observability. That's our product, so we're using it. It's Jira for so-called hot tickets, tickets about incidents. But one thing important to remember is it's better to prevent than to treat, right? So how do we prevent incidents from happening? And it's not only about database evolution, database schema evolution, it's about pretty much everything in Jira. We have a really huge test suite, like 15,000 unit tests. It's only unit tests. And then there are functional tests, there are DB unit tests that test the database, and so on and so forth. We have a CI pipeline that performs those tests for us. And it's actually quite quick because you can get the results in an hour or so when you push the pull request for the first time. So it's quite tight feedback loop, I would say. Okay, we have a staging environment, and we're dogfooding. So the staging environment, this is, again, one of the peculiarities of Jira because of the historical reasons. But we don't have tests. We have only staging and production. And there is actually some of the tests that we run are run on production environment. Okay, as I mentioned before, we have dogfooding instances that we use for everyday work. So when something is broken, angry people, it's not angry customers, it's angry coworkers that come to your desk and tell you, you broke something and you need to fix it soon. Okay. We have synthetic tenants on our production. This is basically something that we, synthetic tenants running on production that when we deploy new code change to the production are very hardly hit so that we can see if there is some anomaly happening and we can pick it up as fast as possible. Okay, thank you very much. That's pretty much it. I hope you have some questions you want to ask now. So we have a question there. Yes? Okay, so since we have this framework of downgrade tasks, you actually can move from any version right now. The thing is that since last year, we're not supporting server customers. Server is the smallest on-premises installation, just one CPU, right? So if you want to, you can use the DC version, which is a cluster version of Jira for on-premises. But still, if you perform an export from an old version of Jira, which is greater than 7.02, if I remember correctly, we will be able to, this is our commitment. You will be able to import it to the cloud. And if you export it from cloud, you will be able to import it to any version of Jira DC that is greater than 7.02. Yes, another question. Okay, you need for that you would need a maintenance window. But what we do is actually we clone the database and we then perform an export from that database. And there's one more thing that you could actually make your lives easier, make your users' lives easier by using the project-by-project migration. So you first migrate all the users so that we know what are the users that are in the cloud version, right? And when the users are in place, you start migrating project by project. So that's one of the ways of dealing with it. That depends on you, how you want to deal with that. Any other questions? Yes?
You said like your production code in one of the 5 stages should be able to work with the old and the new schema.
Yep.
How do you determine like if the database you're on is with the old or the new schema?
We usually use feature flag for that. Since it's the same feature flag that is used for performing the upgrade, right? But it's usually the feature flag, it's easier, much easier that way. Okay, any other questions? No questions. I guess that would be all. Thank you very much in that case. One thing that I want to announce as well is that we're hiring. Atlassian has an office based in Gdańsk, but we're hiring for remote positions, and all developer positions are remote. So you're welcome to apply. And if you do apply, please mention me. Thank you very much.